of NKOS to deliver the welcome address.
I'm sure you're tired of seeing me since morning, so I'll keep this really brief. It's just a formality because we are having this as a separate, slot. I'd like to all of you to this evening lecture, NK Panikkar Memorial Lecture, that is actually being delivered by our Dr. Shailesh Nayak. Of course, the speaker will be introduced shortly, but then we all know Dr. Shailesh Nayak. He has been a former director of NKOS. He was the secretary of the Ministry of Earth Sciences. He has kindly agreed to come down actually to NKOS and then be part of OCCON 23 and also deliver this NK Panikkar Memorial Lecture. I would like, with these brief words, I would welcome all of you to this lecture. I see the seats filling up pretty soon, so I'm sure you'll have a wonderful time. Welcome all of you.
Thank you, sir. Today, we pay homage to the memory of the distinguished Dr. NK Panikkar, a visionary in the field of ocean sciences. Please welcome Dr. M. Baba, former director of the Center for Earth Science Studies, who will share his tributes.
There's a photograph, no? Photo. Thank you. My job is to introduce Dr. NK Panikkar. I don't know how many of you heard about Dr. NK Panikkar, but I am sure you must have heard about the first IOE, Indian Ocean Expedition, International Indian Ocean Expedition. So there is a thing linking between Dr. Panikkar and IOE. I will briefly tell that. Dr. Nedumangat Keshav Panikkar, that is NK Panikkar, the founder of the National Institute of Oceanography, played an important role in initiating the International Indian Ocean Expedition, a landmark in ocean research in our country. He was the father of TEMA. You don't know what is TEMA? The Training, Education, and Mutual Assistance Program of the Intergovernmental Oceanographic Commission, IOC, of UNESCO. And in 1960, the founding year of the IOC, three famous oceanographers, Anton Brun, George Deacon, and Roger Revele, developed a program for the International Indian Ocean Expedition, IOE. They knew that their plans would not fly without the participation of the developing countries bordering the Indian Ocean. They approached Dr. Panikkar as India's member of the Scientific Committee on Oceanic Research, SCORE. Dr. Panikkar at this time realized that the IAOE would help him to put Indian marine research into the mainstream of global ocean research. Dr. Panikkar created the Indian Committee on Ocean Research. Its first task was to plan India's involvement in the IAOE. Dr. Panikkar became the admiral of 4 Indian research vessels participating in the program. He invited leading scientists from all over the world to work on those vessels and to give lectures and courses during port calls of their own research vessels in India. A large team of young scientists, Indian scientists, was trained abroad and on foreign vessels operating in the region under the flag of IAOE. India became a new scientific sea power, as was stated by UNESCO writer Daniel Berman in his account of the IAOE. Dr. Panikkar took up the task of establishing the Indian Ocean Biological Center, jointly set up by CSIR and UNESCO at Cochin for sorting zooplankton collections made by 25 ships during IAOE. Subsequent to his active role in the IAOE as its director, he provided the foundation for the establishment of the National Institute of Oceanography, NIO, in 1966 and served as its first director. Dr. Panikkar promoted all branches of marine sciences and practiced a multidisciplinary approach to scientific problems. Dr. Panikkar, born in 1913 in Kottayam, after college education in Kerala, took his doctoral degree DSc from University of Madras at the young age of 25. The British Royal Commission then invited him for 4 years of research work in the universities of London and Cambridge. On return, after serving as the head of the zoology department of University College, Trivandrum, he became the director of the zoological laboratory at the University of Madras. Dr. Panikkar served also as the officer on special duty at the Ministry of Agriculture and as a member of the National Commission on Agriculture. In 1966, Dr. Panikkar and Dr. McGrahill organized a 6-week training program for 25 young scientists from India, Sri Lanka, Malaysia, Singapore, and Thailand. A good number of Indian senior scientists gave lectures in this program. Finally, in 1969, the first IOC working group on mutual assistance was convened with Dr. Panikkar as chairman. His major message was to invest primarily in young people rather than in equipment and vessels, which tend to rust so quickly in tropical waters, not the scientists. He also saw the need for assistance in creating public and governmental awareness for marine affairs and in building up national organizational infrastructures. Dr. Panikkar made huge strides in establishing several institutions under his dynamic leadership. Over the years, he created a network of 5 central fisheries research institutes in India. They are Central Marine Research Institute, CMFRI, Central Inland Fisheries Research Institute, Central Institute of Fisheries Technology, Central Institute of Fisheries Education, and Central Institute of Fisheries Operatives, CAFO. As a former director of the CMFRI, he served also as the advisor to the Government of India on fisheries development. Therefore, Dr. Panikkar was one of the world's most successful capacity builders in marine sciences. Dr. Panikkar was an elected fellow of the Indian National Science Academy, Royal Society of Arts, London, National Academy of Sciences, and Indian Geophysical Union. The contributions of Dr. Panikkar in various national and international bodies in different capacities are also to be remembered. Chairman of Indo-Pacific Fisheries Council, Chairman of IOC, Member Advisory Committee on Fisheries and Resources Research, FAO, Chairman of Indian National Committee on Oceanic Research, Secretary INSA are just a few. Dr. Panikkar was also a recipient of the Galathea Medal of Denmark early in 1953, Sir Dorabji Tata Medal from the Zoological Society of India, and the Chandragalahora Medal of the Indian National Science Academy. The Government of India awarded him the 4th highest Indian civilian honor of Padma Shri in 1973. In 2009, Dr. NK Panikkar Memorial Medal was created by the IOC to formally honor its past chairman, and IOC instituted NK Panikkar lectures on capacity building in marine science issues at regional and or national levels. I personally had good fortune to meet this visionary when I joined as a research fellow in National Institute of Oceanography. After his long tenure in NIO, Dr. Panikkar served as Vice Chancellor of the Cochin University until his death in 1977. Dr. Panikkar was a great institution builder and laid solid foundations for the ocean science and technology in India. Dr. Panikkar, who left us 47 years ago, was highly respected by everyone, the Ocean Society of India is proud of this father of ocean research in India and remembers him by instituting this Dr. NK Panikkar Memorial Lecture. Thank you.
Thank you, sir. I now invite Dr. N.P. Kurian, President of OSI, to introduce the speaker of the evening.
Good evening, one and all. It's my pleasant duty to introduce Dr. Shailesh Nayak. He doesn't need any introduction, but as a matter of formalities, we are just doing it. Of course, he has warned me not to elaborate too much also, but then there is a limit to condense everything, so he may not like my talking too much, but still I have to record here some of the major things. So, Dr. Shailesh Nayak, after taking his PhD from MS University of Baroda, got specialized in coastal and ocean processes, air-sea interaction, coastal hazards, coastal geomorphology, and geological geomorphic processes. Dr. Shailesh Nayak served for long years in the Space Application Center of ISRO, where he coordinated many important national projects related to the above and established a strong case for remote sensing applications in those areas in the country. Later, during his stint as director of NKOIS, Dr. Shailesh Nayak led the conceptualization, installation, and operationalization of the first tsunami early warning center for India, which is being successfully utilized by the countries in the Indian Ocean Rim. Dr. Nayak then moved to the Ministry of Earth Sciences, Government of India, as its secretary and chairman of the Earth Commission, and headed them for 7 long years. As the secretary of MoES, Dr. Shailesh Nayak had initiated several new programs, centers, activities relating to monsoon prediction, global change, and the use of earth system sciences for overall societal benefit. Dr. Nayak has many professional recognitions, honors, awards, and honorary degrees. He is a fellow of the Indian Academy of Sciences, National Academy of Sciences, and many other scientific societies of India. He is recognized by the International Academy of Astronautics, Paris. Dr. Nayak served as president of many scientific societies and chair of several conferences, organizations, and boards. Dr. Nayak is an honorary fellow of Ocean Society of India. Dr. Nayak has been honored with DSc degrees by Assam, Andhra, and MIT universities. He is a recognized PhD guide of 7 universities and has guided over 10 PhDs. Dr. Nayak has a long list of high-indexed and widely cited publications. He has many awards to his credit, including the Indian Geophysical Union's Hari Narayan Lifetime Achievement Award 2013, Vikram Sarabhai Memorial Award by the Indian Science Congress Association for 2011-12, Bhaskara Award 2010 of the Indian Society of Remote Sensing, and the National Mineral Award 2005. Of course, there are several like that. I'm not repeating all the things. Dr. Shailesh Nayak is presently serving as a director of the National Institute of Advanced Studies, Bangalore. The Ocean Society of India, NKOIS, and the organizers of OSICON 23 are indeed privileged to have a highly acclaimed earth scientist of Dr. Nayak's caliber for delivering the first Dr. NK Panikkar Memorial Lecture. Thank you.
Thank you, sir. We are privileged to have Dr. Shailesh Nayak among us. He will now deliver the Dr. NK Panikkar Memorial Lecture on Ocean Science to Services, a Perspective for Blue Economy.
Thank you very much, Dr. Kurian, for a very generous introduction, and Dr. Baba for introducing the Professor Panikkar. I am extremely grateful to Ocean Society of India for instituting award in the name of Dr. Panikkar. He, as Baba has told, is the doyen of oceanography. Can I have pointer or they will? Yeah. Yeah. The important thing, what struck to me, that he has been a director for, heading the institute for most of his life. But even then, he has taken 22 expeditions. And that shows his interest in the oceanography. And many of them he led as the chief scientist. So all his career, practically every year he used to go for at least one expedition. I think that is something which many of us think that I have this responsibility, that responsibility, I can't go there, can't. So this is, I think, the very important lesson we need to learn from him. And second, which is, I think, very critical, is he was not afraid of taking up new challenges. He was a director of CMFRI when he started on the Indian Ocean expedition, which is quite different than what he was doing. And then he organized all the, as Baba has told, all the fields, setting up NIO, setting up many other institutes, becoming vice chancellor. He touched all aspects that he never afraid of taking any, including in Kerala State Planning Board, So that is, I think, is the hallmark of a great visionary, where whatever responsibility came, he took it up. And I am extremely grateful to Ocean Society of India for asking me to deliver the first. It's really proud privilege for me or anybody else to deliver a talk which is named after Dr. Panikkar. What I had thought is, because this is on the operational oceanography conference, and I thought I will also say that how these services and all that can be converted into economic benefits, what we call as a blue economy. Of course, this audience knows about the importance of the ocean. But the important thing is the UN Sustainable Development Goals very specifically mention about conserving and sustainable utilization of the ocean resources as a SDG 14. And that essentially came from the Rio +20 conference, where the idea came that from a green economy to blue economy. And this shift came essentially because we realized that if we have to survive in the coming 20-30 years, we will have to depend on the ocean. And we should depend on the ocean, but we should not use the resources of the ocean the way we used on the land. And the blue economy means it is resources to be used, but keeping ecology and environment is secured. And when this UN Sustainable Development Goals came, I think we had a very elaborate session on the UN Decade of Ocean. That is essentially to how the science can be used to provide the benefit to the society. So all these things are happening in this last few years, shows that the entire global community, including the political, scientific, social, they think that the ocean is going to be our future. Now, The blue economy, if you see the definition, there are hundreds of definitions. And I don't say that this definition is final. But what I would like to call blue economy as ocean-dependent economic development by improving the quality of life of people. So the livelihood is one which is very important. Including social development is the another. And along with the environment and an ecological security. So whatever we may do has to take into account the environment as well as the ecology of the area. Now, the one which is very important in the blue economy is that how we can use sustainably the bioresources. You know, many of you know that NK has been providing various services on PFZ and all. But what we need, if we have to use the sustainably these resources, we need to find out what is the biological sustainable yield. That means we should be able to provide a forecast or a prediction that what is likely fish catch or yield likely to happen in a given season. And this is essentially more true for to begin with the pelagic fishery, because we know that how the biology is controlled by the physical and biological processes. We have the information about the primary productivity, about the temperature, about the currents, and how we can use this information to provide the forecast. It's as if like, you know, we get the forecast for wheat and rice every year before harvesting. We need to have that system to be put in place, that this is the likely yield and we should harvest this much. I think that is one which is very important aspect which we need to work on. The second thing which is happening is, many of you may be aware also, that the sardine and mackerel, which was essentially available on Kerala and Karnataka coast, and very popular fish in the what typically Malabar coast it is called. After 1985, their catch of both this has reduced while it has increased on the Goa, Maharashtra. Also you start getting these fish in the Andhra and Tamil Nadu. Now there could be many reasons for happening this, but one of the reasons which is that it is likely to be increase in the temperature, that led the northward shift of this fishery. There are a lot of things to be done on this, but the data says that even the year before last, in Maharashtra has a bumper catch of a sardine, which was not earlier even available. So this is there are many such shifts may be occurring, and we need to analyze this data very carefully, because sometimes we may say that because of overfishing, the fish is not available, or there is something else is happening. So we must also see that whether such regime shift is maybe happening in many other areas. There are many other biological resources, and a lot of survey has proved that the deep sea has the tremendous amount of potential. One current estimate is about 3.3 billion tons, which is more or less same as what we are getting from the marine fishery, about 3.7 million tons. So we have almost similar kind of potential area is available, and today morning only Srinivas told me that there is a lot of demand for the forecast for the deep sea as well, because that means fishermen are already aware of it and trying to catch this. There are many other things which is also possible. One is the myctophids, which is not table fish, because it's a lot of fat in it, but it can be extremely useful for the poultry feed. So that also we will need all kinds of food, not only for us, but for the other biota as well. So but all this also needs a new techniques of harvesting them, processing them, and bringing on to the wherever it is required. So the technology also is very critical to address this issue, and in future we may have to depend on these. There are experiments done on the cage culture by NIOT, and it's extremely successful, where you can have a cage and you can grow fish in it, which takes about 10 to 11 months. And this can be also effectively used. But this also has to be transferred to the fisherman. There are other, like ornamental fishery, which is very successfully done in Agati, but it has to be replicated in many other places. The bioactive molecules, there are many bioactive molecules, but the problem is the research stops at identifying biomolecule. That doesn't help, because unless you build synthetic molecule, it cannot be converted into a drug. And you may see thesis after thesis after thesis, which says that I have found this bioactive molecule in X, Y, Z. But how many of them convert into synthetic molecule? And that is where I think the effort should be. The coastal systems are very critical also for the fishery and also to protect us from the various hazards. And this knowledge which we need about the coastal ecosystem, like mangroves or a coral reef, seagrass, in India we have a fairly good understanding about the mangroves, and a lot of work has been done, different types and what it does, how much carbon stock and all that. But the coral reef has not received the same kind of an attention. And I think we need to understand how the coral reef survives, in a sense that during tsunami time, Maldives got completely destroyed, but Lakshadweep, nothing happened. Both were exactly same kind of a. So when you disturb the system, mainly in Maldives for the tourism, it get affected. In Lakshadweep, the tourism is controlled and it survived. So all such things also are very critical, and we also need to understand how the energy is dissipated by the coral reefs. Because if we learn that, and partly that experiment was tried in Pondicherry, where we were able to bring back the beach back by introducing an artificial reef. So there are many such things which we have to learn from this ecosystem and try to utilize them for our purpose. In India, fortunately, we are monitoring every 2 years, and it has increased in last 30 years about 1,000 square kilometer, which is substantial. And naturally, the carbon stock also has improved considerably. This is the most important part. And the important part, if you can see in this figure, the mangroves have increased in Gujarat and Maharashtra, which is industrialist state. So it is not that the industry will destroy the mangroves, not necessarily. It depends on the consciousness of the people and the industry and the government. That will, whatever conservation measures are taken, it's seen very clearly. So this, when you use your knowledge, you can also develop and protect the ecosystem. Both can go hand in hand. The coral reefs, there are two major issues. I won't go into the details of this because of the time, but the one is there is a symbiotic relationship with the algae. And when the temperature increases, the bleaching occurs, which everybody knows. But we don't know whether it is a algae which dies first, and that is why coral die. Because the bleaching actually occurs when there is no algae. Coral doesn't give a color to the. So, but this question is not properly answered, because we have not been able to conduct those kind of an experiment which can answer this. I think this is a very important aspect. The second thing is, we have also observed that the corals which have bleached once doesn't bleach again. And also we know that the porites are less affected compared to acropora. That means soft corals are affected more compared to the... So corals also try to adapt to the higher temperatures. But whether it is happening, we don't have actual evidence. These are some of the observations which has to be backed by scientific evidences. Also, we have to see that the pH, which is also likely to be lowered. Of course, the current experiment says that we do not have that low pH which can affect the dissolution of aragonite. But this also is another important area which we need to address. This is one of the program on the marine biodiversity. It is a part of marine census, which is supposed to be done every 10 years or so, like the census of people, where you find all the biota from surface to the depth and try to understand what is their structure, functions, and all that. And India is leading, CMLRE is leading, and this we have now more than 150,000 new species, which is not new species, total species recorded on this biogeographical information. This is important because when we say that because of the increase in the temperature, we are going to lose species, if we do this kind of a survey every 10 years, then we know that whether it has been what we lost or what we gained or what kind of a changes has occurred. The harmful algal bloom monitoring is done in COIS for quite some time. And this is essentially because of the excess flow of nutrients into the water. But what we need is whether we can have an early warning, whether it's a couple of weeks before, whether we can say that this is likely to happen, then we can warn the fishermen and the others to take care of this. Coastal pollution is another important area which will very critical because when you develop the coastal regions, the population will increase, the industry will increase, and most likely the pollution also will increase, which will further deteriorate the health of the ocean. Now, what we need is the monitoring system, which is 24 stations were monitored, not regularly, but once or twice or thrice in a year. But now the inquiries has started putting a buoy which will continuously monitor the water quality. And this is very important. The second, which is very important, is about the plastic, and especially the microplastic. The microplastic, one, of course, it is, as a pollutant, it is dangerous, but the more important thing is it provides a substrate, hard substrate in a water where there is no hard substrate. So the bacteria, virus can travel on microplastic from place A to place B, and this can become from US to India or India to Australia. So that aspect is not well understood, whether the changes we suddenly saw, invasive species and all, what is the role of microplastic in this? The low oxygen, there are, of course, you know that there is a low oxygen zones are formed in the Arabian Sea, also in Bay of Bengal. But the current understanding is that the level is still not reached. The pH is still above it's dissolved. So this kind of a experiment we need both in the open ocean and the coastal to continuously measure the pH and oxygen and the other parameters to understand that what is happening in this area. The tourism is another major area which can generate a lot of income. And last 3 years, there is what we have started is certifying the beaches, that is called blue flag beaches, which is essentially identified area for swimming. It may be 500 meter, 1 kilometer, 1.5 kilometer, where the safety is guaranteed. There is a facility for your bathing, changing rooms, and all other things. And currently 10 beaches have been identified on this. And this is a great success because it also provides the education about the environment. While you can see this beach very neat and clean, which is hardly you see other beaches. There are a lot of beach cleaning programs that we are doing, but again, the people are not conscious to keep the beach clean. But this certification will go away if you are not keeping clean. So this is another way, and most of these beaches are self-sufficient. I mean, the government has not to put any money to maintain them. The next is the minerals, both the coastal and deep sea minerals. Now, in this, we have a very large quantity of coastal placer minerals, especially ilmenite, rutile, and ilmenite specifically is almost 22% of the world reserve. And it is used for many, the titanium comes out of this and many other rare earth. Now, we don't have a beneficiation plants for this. Most of the ilmenite is exported to Japan, and then we get it back. So when we have certain reserves, I think we need also to build the technology. And this is a very high value, and it is roughly estimated as $150 billion, which is quite substantial money, which can dramatically change the coastal economy of the coastal area, especially Kerala, Maharashtra, Tamil Nadu, and Andhra. The deep sea mineral is a little bit futuristic, but we need to know that what kind of reserves are. The polymetric nodules, for about 20 years of research, we know it has a very high reserves. And initially it was only for, the manganese, cobalt, nickel. But now we also know there is a large amount of rare earth along with it. And that is what we need to do. One good thing is that the beneficiation and all that has been done. And the next is the build to technology for mining, which is being done into the deep sea ocean. Similarly, for the hydrothermal sulfides, where you can have a gold, silver, this exploration also has been taken up. And the cobalt is the another thing which is very important. The another science questions which we have to answer with the hydrothermal sulfide is, we know that the life originated in this kind of a region. But the question is whether it is still happening or it happened only 3.5 billion years ago. So these are some of the questions also we need to answer. As we do more and more activity in the ocean and the coast, the water is going to be a major requirement. And the technology developed on the low temperature thermal desalination by NIOT is one which is providing fresh water to the Lakshadweep Islands. 3 islands now, and the 6 more are likely to happen. Same technology can be also used in the thermal power station. This has to be scaled up. And the major thing is that whether we can scale it up to a level where we can have a 10 million liters a day, which can supply water to a city. I understand that the project report is prepared, and there may be a future, there may be the funds may be available. But these are some of those things which is very important now for us to invest in, because in future this water is going to be a critical area. And the advantage of this technology is that it is eco-friendly. Unlike the RO, which discharges very high saline water back to this doesn't do so. So, because this doesn't use 100% water, it uses about 8 to 10%, the 90% again goes back. Also, there are the evidences that some of the metals like nickel, cobalt, lithium, and they have a high concentration of metal in water if you go to 800,000 meters. I discussion with the director NIO, and then they found that yes, it is quite high and could be possible to recover. But how to recover, there are different techniques, and I think NIO is likely to work on that. So this kind of a new thinking has to come for the metals, and many other things which we know. The technology is also under development, like the remotely operable vehicle is already built. The mining crawler for the manganese nodule is also have been tested. The soil tester, which gives the strength, mechanical strength of the seabed, is also available. So basically, we have the technology built. Now, this has to go into a commercial kind of then only it can be replicated and the many can be done. Of course, the submersible, which manned submersible, is also being planned. I understand that 500 meter will be tested next year, and this will go in 25-26 time frame up to 6,000 meter. Now, the important in this is like what we saw today, Chandrayaan. One is, of course, you reach there, but that also has so many other technologies which has come and which could be utilized for many other things. So this is going to be another major contribution of Indian scientists to when man can reach right up to the bottom of the sea. The energy is very critical. Of course, there are many experiments which are being done to harness the wind, offshore wind farms. And many countries have been doing. The important thing is that you also need an infrastructure to deploy such windmills into the sea and then getting power back to it. So that is also equally important. And another resource which we have is the gas hydrate, which is a solidified methane and water, is a very large number. It is almost like can last us for the hundreds of years. So, but that harnessing technology is not available. So that is where we need to work on it. Now, hazards and response mechanism, we have extremely good systems because any economy has to develop, also has to take care of what are likely hazards. So cyclones, tsunami, coastal floods, erosion, all this we have fairly well understood, and then early warning can be given. But the new industry which has to come up, we have also identified the vulnerable areas. The work done by NKOIS is very landmark in this, where the entire country's coastline has been analyzed for different kinds of hazards, and the vulnerability has been assigned by a model which is based on GIS. And this is working pretty well, and I'm sure that if any new thing has to be done, this vulnerability maps will be very useful. All this, the ocean observations is very critical, and we cannot allow us to be on the emphasis should be lowered any time on the ocean observations. Because many times I have seen that people think that by using computers, models and everything, but everything will need observations. And I think we have to continue to have this information on the ocean, all the physical, biological, all this is going to be very critical. So the expeditions like IIOE-2 or the Ocean Decade, all that emphasizes that why the observations are very critical. And the large amount of data is already collected and put it into an information system. But the next level, I think it has to be a digital ocean where you can get information about any particular parameter without worrying from what kind of a platform that information is coming. Because today temperature you may get from satellite also you may get from thermal or a microwave, on measurements with the drifting buoys, Argo floats, so many different techniques are available to get a temperature. But as a user, I am interested in only one value. So we need to build those algorithms to get this value for a point or across a transect or given an area. And I understand this is in very advanced stage in inquiries, and we will be released very soon. The other important thing for the blue economy would be the climate change advisories. Whether we can provide information about cyclone, seasonal, sea level, biogeochemistry, well in advance. So this activity is now undertaken as a part of Deep Ocean Mission, and I'm sure that in next couple of years, we will have the initial advisories from this coming up. Now, lastly, what we need for this blue economy, what we need is the ecosystem restoration and how we can continue the utilization of resources and at the same time we restore the ecosystem. I mean, that is the challenge which we always have to work on. The second is the coastal and marine spatial planning, so that we can have the balance, the counter, both the development and the environment can be maintained. But the issue is that there are different kinds of information which is required. Has to be collected. But India is in much better situation because as far as the coast is concerned, there is large amount of spatial data is available. Only on the marine side, we have to collect those information and integrate them both. So this is another area which is very important for blue economy. The third is, what are the indicators which can say that, okay, this system is sustainable? I think we are all saying, but what are those indicators, what is and how we should measure is another area which we'll have to address. The other is we will have a different kinds of data sets, not only the scientific data, but also the environmental data, also the socio-economic data. How do we integrate them? So this is another challenge which we have in future. And of course, I think the digital ocean is one which would show us a path to integrate the different kinds of data. I think this is what we need to further promote. The capacity building is, we have seen that it is a major area which we need to do. And we also need to build an institutional framework and the governance structure. Because when you say about the blue economy, there are different departments, ministry, the stakeholders, the shipping, the power, the security, all different kinds of people are involved. And that is what the Ministry of Earth Science is doing, to build that framework to bring all the different line departments into this, which directly, indirectly depend on the ocean. But they depend on the information which they need on the Ministry of Earth Science. So this institutional framework and the governance structure has to be built up. And I'm sure that if we have the responsible stewardship of the ocean, that would be a great investment for us, and the dividend will come for the future generations. Thank you very much. No question.
Do you want to take any questions? Sir can take a few questions if you have any. Okay, sir. Okay.
We are tired.
So 1 minute, sir. So can I request you? Thank you for the enlightening talk, sir. It is now time to honor our guest of the evening. I request Dr. M. Ravichandran and Dr. NP Kurian to felicitate Dr. Shailesh Nayak.
congratulations for the excellent talk.
It was okay?
Thank you, sir. I now welcome Dr. Mani Murali, General Secretary of the Ocean Society of India, to present the vote of thanks.
Yeah, good evening to all. So, it's my great privilege to say a vote of thanks at this Dr. NK Panikkar Memorial Lecture, first lecture, because I am from the same institute, what he instituted in 1966. That institute subsequently produced lot of great oceanographers, subsequently produced lot of great scientific leaders. So if you look back and map the scientific clan, I think most of us will fall into Dr. NK Panikkar's scientific clan. So that is one of the great proud for all of us. When in our normal governing council meeting, when we are talking how to felicitate the pioneers in oceanography, so Dr. Baba came out with an idea that we should initiate a memorial lecture in our OCCON conferences. So, Ocean Society of India is trying to felicitate pioneers in oceanography, gives award to the current researcher who is excelled in his research in oceanography, and giving PG dissertation awards to support or to encourage the youngsters. So in all angle that we are balanced way, we are trying to do service related to oceanography. So I sincerely thank Dr. Baba for floating this idea first. And Dr. Patabi, who is one of the governing council member, convener OCCON 23, properly conveyed this to local organizing committee chairman, director inquest, Dr. Srinivasa Kumar. He readily accepted this proposal and happily kept this Dr. NK Panikkar Memorial Lecture, first lecture in OCCON 23. So I sincerely thank Dr. Patabi and Dr. Srinivasa Kumar for initiating this great movement. We heard about Dr. Panikkar through Dr. Baba. We heard about Dr. Shailesh Nayak through Dr. Kurian. So I find a lot of similarities between them. They are the institutional builders, they are the visionaries. So none other than you, sir, would have given this, delivered this great lecture. So you are the opening batsman, and we assure you all that this lecture, this Dr. NK Panikkar Memorial Lecture will go on forever in all OCCON conferences. If I miss the Ocean Society of India's Governing Council, always we support the new ideas, and we are very open to receive any ideas to any one of us. We even wanted to locate the Dr. NK Panikkar's family, but unfortunately because of very shortage of time we could not do it. I give you an open request to all of you, if any one of you have any link with any of the families of Dr. NK Panikkar, please get in touch with us. because we will be happy to invite in the next OSICON on this NK Panikkar lecture. I think from morning we are listening scientific channel, so now time to shift to entertainment or cultural channel. So dancers are waiting. So without wasting any time, so I thank each and every one of you who are present here. If in any case, if I missed anybody, it is 100% unintentional.